Today I'm going to electroplate copper. This process will make a regular quarter look like this. So, how does this happen? The first concept essential to understanding electroplating is reduction-oxidation reactions, or redox reactions. A redox reaction is any reaction in which the oxidation number changes due to the gain or loss of electrons. In these types of reactions, electrons are transferred between two species. In the oxidation half of the reaction, shown in blue, electrons are lost and the positive charge of this species is increased. In the reduction half of the reaction, shown in pink, electrons are gained and the positive charge of this species is reduced. In my reaction, my oxidation reaction was copper solid reacts to make copper plus 2 aqueous plus 2 electrons. My reduction reaction was copper plus 2 aqueous plus 2 electrons reacts to make copper solid. The oxidation half of the reaction also corresponds to the anode of an electrochemical cell, while the reduction half is the cathode. Electrochemical cells help to facilitate spontaneous redox reactions, and they induce the reaction to create electricity in the form of volts. In an electrochemical cell, the anode and the cathode are both connected to a measuring device. The two half cells are connected by a wire. Through this wire, electrons move from the anode to the cathode. They are also connected by a salt bridge, which is full of ions that maintain charge balance and close the circuit. In this type of electrochemical cell, energy is produced because the redox reaction is spontaneous. However, when it is not spontaneous, electrolysis occurs. Electrolysis uses a battery or other power source to drive a non-spontaneous redox reactions. The two electrodes are also connected by a wire, however, there is not a salt bridge. The electrodes are dipped in the solution called electrolyte, which is where the electrical current passes through. Electrolysis is the process used to drive electroplating. In electroplating, the electricity made from electrolysis is used to coat one metal with a very thin layer of another metal. I coated a quarter, my anode, with copper, my cathode. The copper electrode and the quarter were placed in an acidified copper sulfate solution. This allowed for the electrons from the copper strip to move to the surface of the quarter. The solution was made of 1 molarity copper 2 sulfate and 1 molarity sulfuric acid. I poured some of it into a beaker. Then I cleaned my copper strip and my quarter with steel wool. I attached the copper strip to the positive battery terminal, and this was my anode. The quarter was attached to the negative battery terminal, and this was my cathode. I then placed the copper strip into the solution and then held the quarter into the solution to electroplate it with the copper. This is my completed cell, and when I took it out, I had a copper-plated quarter. To reverse the reaction, I switched the anode and the cathode. This took the copper off of the quarter and returned it back to its normal self.